The problem is from GATE 2016 mathematics paper, question number 37. The problem given is, let M equal to the 3 cross 3 matrix with entries A, B, C, B, D, E, C, E, F. Be a real matrix with the eigenvalues 1, 0 and 3. If the eigenvectors corresponding to 1 and 0 are the vector 1, 1, 1 whole transpose and 1 minus 1, 0 transpose respectively, then the value of 3f is equal to dash. So it is given a 3 cross 3 matrix and the three eigenvalues as 1, 0 and 3 and two eigenvectors corresponding to the eigenvalues 1 and 0 as these two vectors. Then it is asked that the value of 3f is equal to. So the NPTEL reference to solve this problem is Module 7, Lecture 26 with the title Eigenvalues and Eigenvectors of Linear Operators. This lecture is from the topic Linear Algebra by Dr. K.C. Sivakumar. He is from Department of Mathematics, IIT Madras. Even you can watch this reference video using this YouTube link. So now coming to the solution. So let me write it is what it is written. So given the matrix M equal to A, B, C, B, C, E, B, D, E, C, E, F. C, E, F. And 1, 0 and 3 are eigenvalues of M. And it is given that one more condition 1, 1, 1 whole transpose and 1 minus 1, 0. 1 minus 1, 0 are the eigenvectors of M corresponding to the eigenvalues 1 and 0. This is the hypothesis given. So then it is asked that the value of 3f is equal to. So from this condition or given the matrix M 3 cross 3, we can observe that from the given matrix M we have trace of M is nothing but the sum of the diagonal entries, that is nothing but A plus D plus F. Yes, as the sum of the diagonal entries are nothing but these three, and that is nothing but by the given conditions or by the given eigenvalues as nothing but 1 plus 0 plus 3, and hence we have A plus D plus F equal to 4. This is one condition we have involving the variable F. And similarly, by the given conditions, as this vector is the eigenvector corresponding to the eigenvalue 1 and this vector is the eigenvector corresponding to the eigenvalue 0. So we derive some more conditions or some more equations similar to this equation, and then by solving all such kind of equations we get the value of F. So let's see how it is. So since it is given 1, 1, 1 whole transpose, given 1, 1, 1 is eigenvector of M with respect to the eigenvalue 1. So we have that A, B, C, C, D, E, B, D, E and C, E, F times the given vector 1, 1, 1 is nothing but the eigenvalue time the same eigenvector 1, 1, 1. That is what it is given. So by solving this matrix multiplication we get, or let okay, so we get A plus B plus C equal to 1 and B plus D plus E equal to 1. Similarly, C plus E plus F equal to 1. And similarly, we have one more condition that 1 minus 1 0 is eigenvector corresponding to eigenvector of M. This is transpose corresponding to the eigenvector, eigenvalue corresponding to the eigenvalue 0. So what does this mean is, similarly we have the equation A B C B D E C E F times 1 minus 1 0 is equal to 0 times 1 minus 1 0. And by solving this matrix multiplication we get A minus B equal to 0, B minus D equal to 0, and C minus E equal to 0. Right? Yes. And hence from this we see A is nothing but B and B is nothing but D and C is equal to E. And we have the other conditions as, from the trace we have A plus D plus F equal to A plus D plus F equal to 4 and A plus B plus C equal to 1, B plus D plus E equal to 1 and C plus E plus F equal to 1. Yes. So in total, we have these equations. Now, by solving all these equations, we have to derive the value of f. So by substituting these values in these three equations, we see what we get. So when we substitute these three values, we get that a plus b, that will become 2a plus c equal to 1, and hence we have, this implies 2a plus c equal to 1. And similarly, it represents the same value as we have b equal to d, and d is nothing but a again. So we get the same equation again, 2a plus c equal to 1. But here we have 2c plus f equal to 1. And we have a plus d plus 4 equal a plus d plus f equal to 4. And from this we have 2a plus f equal to 4. And now by solving, okay, by solving these two equations, this one and this one, we see what we get. By subtracting these two equations, we get 2a minus 2c equal to 3, and this implies a minus c equal to 3 over 2. And we have another equation involving a and c here. So by solving that equation and this equation, we get, by adding these two equations, we have 2a and 3a, that is 2a plus a 3a equal to 1 plus 3 over 2, that is nothing but 5 over 2. That implies the value of a is 5 over 6. So we have the value of a, and by substituting this value of a in this equation, we see what we get. We have 2a plus f equal to 4, 2a plus f equal to 4, and we have the value of a as 5 over 6, and that is nothing but 4 minus 5 over 3. Hence we have this as 12 minus 5, 7 over 3. So the value of f is 7 over 3. But it is asked that the value of 3f. So from this we have 3f is nothing but 7. So that is what it is asked. So hence we have the value of 3f is 7.